How do we swap a node back in a linked list using recursion? Well, like all recursive problems, it's helpful to start thinking about the simplest case you can imagine first. And in this case, we've got a list where swapping the head node back is going to do nothing. So let's imagine that. So let's imagine we're working on a call to swap back, and the head node that we're working with is this node down below, and it's a single node, singly linked list. And the index that we're trying to swap back, let's say, is indeed 0. Well, this is a base case because there's no node for us to swap back with, right? The very next node is null. That means we can't swap ourselves back. And in this case, the only thing we have to do is say, all right, return head, right? So in the base case where there is no next node, we simply return head because this list has no more, it can't be swapped back. This node cannot be swapped back. So let's think of a slightly more interesting case where we've got a 2-item linked list, and the length of this list is 2. And what we'll imagine is that our head node now refers to this y node, this node with data y. And our goal here is to have no longer a y z null list, right? But instead a z is our new head, y is our next node, and finally y will refer to null. We want this to be the outcome of swapping back index 0, right? We're swapping back y, so it is going to swap with z. Right? So if we were to draw these letters out in their original order and then fix the arrows, what we would say is the original head was y, right? And let's think about what these arrows are going to look like in the case where we've swapped the first node back. So in the case where we've swapped y back to z, right, z is going to become our head node. Z's next node is going to refer to y. Y's next node is going to refer to null in this case, but more generally it's whatever previously came right after z, right? So let's add some labels here. And one of the ways to think about a reference or a reference variable is that it's just a label that we're giving to an object. Right? So let's imagine we've already got one label, head, and head refers to this node here. When we're swapping back at index 0, we're setting up a new head value, which is the next index, or sorry, the next property, the next node after our head. So let's set up a label called new head, and we would assign to new head the next property of our original head, right? And finally, let's set up a reference to the next node, right? And so the next node is going to be new head's next property. This might be null, this might be some other node in our list. So it helps before you try and update any of your reference arrows to set up 3 labels, right? The first label you get for free from the parameter named head. The second label is one you'll have to declare in this particular base case. And the third label is also one that you'll have to declare. All right, so if I use a different color here to also assign each of these labels to their original letters, head was y in this case, new head is z, and next was whatever came after new head originally, right? The way that you sort of untangle this series of references is you would then assign and say, all right, new head's next is going to be what was head, right? So we might say, new head, your next value is going to be head, right? And so that's what established this reference here, the reference from z to y. How do we establish the reference from y to whatever came after z? Well, to do that, we would say head, your next reference is now going to be next, right? Because next is the label that we gave, or the reference we set up to refer to the element that came after z. And so what we've done is we've reestablished these two arrows, right? We've set up this arrow back, and we've set up this arrow from y to the next element. What's left to be done after this? Well, in this case, all we need to do is return the new head, right? So z, the new head label, would be returned, right? Because this is the new head of the list that has swapped backwards the node y to be behind z, right? The previous head is now going to be after the new head in the order of this linked list. So this is the second base case. Let's talk about the recursive case. What is the recursive case? So let me erase some of these markings and set up a third node here. Okay. So our third node is going to have a value of x. And it turns out in this recursive case, if you solve remove recursively, you're going to see that there's a very similar strategy that gets employed here. All right, so now that we've cleared those away, let me pull in our third node. So x is our third node, and it's our new head. And just to give a rough estimate of what these labels are, this is item 0, this is item 1, this is item 2, right? So what would happen if we called swap back and we said swap back was being called with head, which refers to this node here. So this is our head node, and our index that we're trying to swap back is 1, and those are the only two arguments we need in order to call swap back, right? So the goal here is we have an input linked list whose elements are x, y, z goes to null, and our output, or the result of calling swap back with head and 1 as the index, should be x, z, y, null. And notice that these two elements, the element at index 1 was swapped with the one behind it, right? So this will cause these two to swap back. Well, in the recursive case, we know that we're in the recursive case when we are not at index 0, right? Here we're at index 1. And so what we're going to say is we don't know how to swap back some element that's after the current position we're at in the list, because head's index, as far as it knows, is 0. So our goal then is to call swap back on the rest of the list, right? So our goal then is to say, all right, we're going to call swap back on the rest of the list recursively. So we're going to swap back the rest of the list. And how do we reference the rest of the list? Well, that's head.next, right? So head.next is saying, all right, we're calling swap back, and we're going to only call swap back on this part of the list. But now our index is not going to be 1. Our index is going to be 1 less than 1. And so more generally, you can imagine this is going to be index minus 1, right? Because this is 1 less than whatever index we originally called it on. In this case, it would be 0, right? So this is the case where we're calling swap back on node y, and the index is 0. Well, in this instance, we already know how that works. This hit our base case that we just talked about, right? And so our base case was a problem that we've already solved. Our base case successfully swapped these two values with one another. And what did our base case return? Well, it returned, so let me just write out the arrows of what our base case would have done, right? So our base case would have assigned the next value of y to be null, and the next value of z to be y, right? And what our base case is going to do is it's going to return z, right? It's going to return the new head of the linked list with those two elements swapped. So what we want then is not for this reference to actually point to y, right? We want to say wherever we called swap back recursively, assign your head.next, right? So this head still refers to this head here, right? Where we call this recursively, I want your head.next to be the result of calling swap back recursively on the rest of the list with index 1. And that has the impact of saying, all right, well, the head node's next on the outermost call is no longer a reference to y. It's now going to be a reference to this node here, right? So what do we have? Well, let's follow from our head forward, right? So head is x. X is pointing now to the result of calling swap back recursively, and that was our second base case that we talked about, and that's the node z. And z's next, after that recursive base case ran, would be y. Y's next was null, and this is what we were hoping to achieve. So all that's left to be done in our recursive case is return our head back to the caller, right? So the recursive case just returns the original head that it began with, because the swap happened after it. The key intuition on these more intricate recursive linked list manipulations is to remember that every time you call swap back recursively, you're assuming or guaranteeing that it's going to return to you the sublist of the list that you're currently working with whatever index shifted to be relative to that sublist swapped back correctly. And the base case then is when you reach the sublist where index is 0, and that's when you actually do a swap, or if you reach a point where heads next is null, that means that you're going to get just the same head value back or the same sublist back, and there's no work to be done. That would only happen when your index is too great to actually exist on this list. And that's how you swap an element back using recursion.